YouTube channel. In today's video lesson, we are going to be taking the fourth section of this video lesson. As you can see on the board, we have Jamb mock physics question 2024 by DH2O. We are in part 4. Okay, on the board we have it as question number 22 because we have treated 1 to 21. So if you have not watched our previous video where we talked about question 1 to 21, please do that. Okay, in question number 22 we have the unit for sound energy is what? What is the unit for sound energy? Many students will be quick to shade your decibel. If you do that, you are wrong. You are very wrong. They didn't say you should look for this unit of sound. The unit of sound is decibel, but the unit for sound energy, because it is energy, the answer is joules. Wow, just don't trip. Question number 23. Calculate the heat energy required to vaporize 50 grams of water initially at 80 degrees Celsius if the specific heat capacity of water is 4.2 joule per gram per Kelvin and the specific latent of vaporization is 2260 gram per degree Celsius. Wow, very cheap. So let's do the solution to number 23. How do we demystify this problem? Very easy. Now, remember the quantity of heat needed to raise the temperature of a body is called thermal heat. Okay, it's called thermal heat. The heat needed to raise temperature from 80 to 100 or from 20 to 40 degrees Celsius is called thermal heat. And the formula for thermal heat is that thermal heat is MC change in theta. This is your mass. This is called specific heat capacity, while this is called change in temperature. So this one, it involves change in temperature, is the quantity of energy or the amount of energy required to raise the temperature of a body. But when there is a change of state, the heat energy required to cause a change of state is called your latent or hidden heat. And the formula is ml. So we have plus ml. Your m still represents mass, while your L is called specific latent heat. Latent heat. So there are two types of specific latent heat. It could be specific latent heat of fusion, when the substance changes state from solid to liquid, or specific latent heat of vaporization, when it changes from liquid to gas. Okay? So in this particular question, we observe that there was a rise in temperature and a change of state. That's why we combine these two formulas together to get the total amount of heat needed to do that. So all we need to do is to take our parameters given, substitute into this formula and get our answer correctly. So what is the mass of the water in the question? 50. So what we have here is 50 times specific capacity is what? 4.2. Remember, we were supposed to convert our mass from gram to kilogram, but we don't have to do that because the specific heat capacity is also given to you in grams. So whenever this one is in gram and this one is in gram, there's no need converting. So you have times change in temperature. The temperature they gave us is 80 degrees Celsius. Remember that the water vaporizes, and for water to vaporize it must get to 100, so that we have 100 minus 80, okay, plus mass here is also 50 times the what? Specific latent heat of vaporization is what? Is 2260, okay? So what we have here is 50 times 4.2 times 100 minus 80 will give us 20 plus 50 times 2260. So let's multiply this and multiply this, then we add it up together. 50 times 4.2 times 20. 4,200. What we have here is 4,200 plus 50 times 2260 113,000. 113,000. So let's add it up together. 4,200 times plus 117,200. Wow. So we have 117,200 joules. That's so interesting. So the answer to this question is option what? Option C. 117,200 joules. Wow. Thank you very much. Now let's take the next question. Question number 24. Question number 24. Now, a block of mass 50 kg is dropped on a spiral spring from a point 10 meters above of force constant 4 times 10 raised to the power 4 Newton per meter. Find the maximum compression of the spring. Very easy. Remember what we have here is this, is that this load is placed on top of this spiral spring, okay? By the time this load is placed on the spiral spring is going to compress. And when it compresses, we call it compression or we call it extension. They are the same. We call it extension or compression. So what we observe is that this load, we do work on the spiral spring by compressing the spiral spring. And because height was mentioned in this question, it means that the energy here must be what? Must be potential energy. If they had measured speed, the energy would have been kinetic energy. Remember, potential energy is the energy due to height, while kinetic energy is the energy due to speed. So in this place, because height was mentioned, it is your potential energy that is converted to elastic energy by compressing the what? The spring. And remember, in my previous video, I gave you the 3 important formula for elastic energy. And these formulas are 1 over 2 Fe, 1 over 2ke square, and F square over what? 2k. These are the 3 important formulas for elastic energy. So what we are observing here is that potential energy is converted to what? Elastic energy. So we can say potential energy is equals to elastic energy. The elastic energy can also be called your strain energy, okay, or the work done by an elastic string. Now, what's your potential energy? The formula is mgh. What's your elastic energy? The elastic energy formula you are going to use will be determined by the parameters given to you in the question. In the question, we are told to find the extension or compression, and they gave us force constant. So we have E and K. So you look for the one that have E and K here and then use it, which is this one. We are using 1 over 2 ke square. 1 over 2 ke square. So we can say that mgh is 1 over 2 what? Ke square. From there we can get our E. So if I cross multiply, I'm going to get 2mgh is equals to ke square. Okay, is equals to ke square. So what do we do now? Very easy. We are looking for extension. We have 2 times the mass. The mass is 50 grams. So you have 50 times gravity is always what? 10 times height. The height here is what? 10 equals to ke square. Our k is, please let's create a space for ourselves. Since we have solved this question, let's create a space so we can solve it. Now watch this. Remember we said that mgh is equals to 1 over 2 ke square. Okay, now if you cross multiply, you have 2mgh is equals to ke square, so that you have 2 times your mass. What's the mass? The mass is what? 50. Gravity, what's your gravity? 10. Your height is here, is what? 10. Equals to k. K is what? 4 times 10 raised to power 4 e square. So let's multiply 2 times 50. That will give you 100. 100 times 10 will give you 1000. Times 10 will give you 10,000. Equals to 4 times 10 raised to power 4 e square. So we divide both sides by 4 times 10 raised to power 4 divided by 4 times 10 raised to power 4. This optimize this. You have e square equals to, Let's do this quickly. I guess this will give us 10,000 over, here you have 4 zeros, so you have 40,000. And this can cancel this. You have 10 over 40. This cancel this, you have 1 over 4. And that will give us 0.25 joules. Sorry, we are looking for extension 0.25. So what do? E squared is 0.25. So E will give us the square root. Remember, you have E squared here, not E. You have square root of 0.25, and that will give us 0.5 meter. Let's confirm this to our calculator. Square root of 0.25. Yes, we have 0.5 meter. So our answer is not A. Our answer is B. Yeah. Thank you very much. We are going to take more questions on this video lesson. Let's take more questions. Question number 25. An engine raises 100 kilogram. Question number 25. An engine raises 100 kilogram of water through a vertical height of 60 meters in 20 seconds. What is the power of the engine? Very easy. You know your mechanical power. This is solution to question 25. Your mechanical power is equals to work done over time. So your power can be your work done over time taken, okay? Or power can be energy over time, okay? Your power can, if it is energy, it can be potential, which is mgh over t, or it can be kinetic, 1 over 2 mv squared. We have 1 over 2 mv squared over t. So power can be potential energy over time, or power can be kinetic energy over what? Your time. Are we together? So take note of that. So this is your formula for power. The last formula for power is that power can also be equals to force times velocity. In this particular question, they said that the mass of the object is 100 kilogram. This is the mass of water through a vertical height of what? 60 meter. Your height is equals to 60 meter. Okay, the time taken is what? 20 seconds. And then don't forget that gravity is 10 meter per second square. Now, if they measure height and you are looking for power, it will be potential energy over time. But if they measure speed and you are looking for power, it will be kinetic energy over time. So in this problem, we have that power is equals to mgh over t because it's potential energy over time. So your power will be 100 times 10, which is your gravity, times your what? 60 all over time, which is what? 20. Now if I use this to cancel this and use to cancel this, we have 3. So we have 100 times 10 times 3. That will give us 3,000 watts. Wow. We have 3,000 watts. Okay, that's our power. So the answer to this particular question is what? Is B. And then let us go to question number 26. He said a thermometer has its steam marked in millimeters instead of degrees Celsius. The lower fixed point is 30 millimeter, while the upper fixed point is 180 millimeter. Calculate the temperature in degrees Celsius when the thermometer reads 45 millimeter. Wow, very, very easy. Very, very easy. Very, very easy. Now let's quickly solve this question before we continue. Let's quickly solve this question before we continue. The question says that a thermometer has its steam marked in millimeters. Okay, don't forget that your thermometer reading has its upper fixed point as 100 degrees Celsius and lower fixed point at 0 degrees Celsius. Now they are comparing the Celsius scale to a millimeter scale. The millimeter scale says that their upper fixed point is 180, so you have 180 millimeter, while the lower fixed point is 30 millimeter. Are we together? Okay, now let us do this. Remember that they said we should calculate for the temperature when it reaches 45. So let's mark a point here as 45 millimeter. Okay, let us calculate for the particular temperature in degree what? In degrees Celsius. Now, if you want to do this, what do we simply do? We have that you have x minus 0 over 100 minus 0 equals to 45 minus 30 all over 180 minus 45. Okay? So we have x over 100 equals to 15 over 180 minus 45 will give us 135. So what do? We simply cross multiply so that we have 135x is equals to 15 times 100. So you divide both sides by 135, and that will give us 15 times 100 is 1,500. So over 135. Let's quickly divide that and see our answer. So we have 1,500 divided by 135. That will give us 11.11 degrees Celsius. Okay, let us see the option. Wow, it seems like the right answer wasn't given in the option. So I don't think there's no answer here. So let's take the next question. Question number 2. I said the sound. Okay, so we have a piece of iron weighs 250 Newton in air. Okay, and 20 Newton in. We have a piece of iron weighs 250 Newton in air and 200 Newton in liquid of density 10 raised to the power of 3 kilogram per meter cube. The volume of iron is what? What is the volume of the iron? Now let us quickly solve this question. The weight of the iron in air is 250. So we write that. That's solution to number 27. The weight of the iron, we have weight of object in the air is 250 Newton. Okay, and 200 Newton in a liquid of density. So the weight of the object in the liquid is 200 Newton. The density of the liquid is 10 raised to the power of 3 kilogram per meter cube. Are we together? Okay. Then you have that. What is the volume of the object? What is the volume? Remember, your gravity is always 10 meters per second squared. So what do we simply do? We are simply going to solve this interesting question. Remember that your all thrust is equals to the weight of object in air minus weight of the object in the liquid. Okay? And it's also equals to density of the liquid, volume of the object in mass times gravity. Now we can sum up these two together and use it to solve the question. What is the weight of the object in the air? It is 250. So we have 250 minus your what? 200 equals to density of the liquid is 10 raised to the power of 3. Volume of the object we don't know times gravity. Wow. 250 minus 200 will give us 50 equals to 10 raised to the power of 4 times volume of the object. So we divide both sides by 10 raised to the power of 4. So this cancel this. Volume of the object will give us what? 50 divided by 10 raised to the power of 4. Let's quickly do this. 50 divided by exponential 4. So we have 5 times 10 raised to the power of minus 3. We have 5 times 10 raised to the power of minus 3 meter cube. That's the answer to the question. So we are likely to say that this is minus 3, okay? The answer is not A, it's not B. The answer is what? C. 5 times 10 raised to the power of minus 3. Let's take question number 28, class. 28 says that calculate the velocity ratio of a screw jack of pitch. Now, this is solution to number 28. The pitch is 0.3 centimeter, okay? If the length of the tummy bar, the length is 21 centimeter, what is the velocity ratio of a pitch? Remember, for a screw jack, the velocity ratio is equals to 2 pi arrow over pitch or 2 pi L over pitch. If this question happens to come out in your exam, please do not fail it because it is very cheap. So what do we do now? We use this one because they gave us the length. So we are going to use this one to solve the question. Not this. This one is when they give you the radius of the tummy bar. So this is what they gave us. We are going to say velocity ratio is equals to 2 pi L over what? Pitch. So you have 2 pi times the length. Remember, this and these are in the same unit, so there's no need converting. So we have 21 over 0.3. So that we have 2 pi times 21 will give us 42 pi over 0.3. Let's quickly divide 42 over 0.3. I guess we are going to have 140. Let me confirm. 42 divided by 0.3. Wow, we have 140 what pi. That's the answer to the question. That's the velocity ratio of the screw. So the answer is not A, it's not B, it's not C. The answer is what? D. Now let's take question number 29. Question number 29. Let's take question number 29. The diagram on the board says that a capacitor of 10 microfarad is connected in series with a cell of 12 volts. As shown, calculate the energy stored in the capacitor. Now, there are 3 formulas used to calculate for the energy stored in a what? In a capacitor. And what are the formulas? The energy stored in a capacitor, are given as 1. Energy is 1 over 2 QV. That's 1. 2. Energy is 1 over 2 CV square. That's 2. 3. Energy is equals to Q square over 2C. Now, these are the 3 formulas used to solve the energy stored in a capacitor. Now, let us analyze this question and see the formula that will be convenient in demystifying this problem. They gave us a volt of 12 volts. So, our voltage is equals to 12 V. Okay? Now, they gave us the capacitance as what? 10 microfarad. Remember, if you are given a microfarad, you have to convert it to farad because the unit for capacitance is farad and not microfarad. So we multiply with 10 raised to the power of minus 6. That will give us 10 raised to the power of minus 5 what? Farad. So that's what we have here. Why this is the volt. So if you see that you are giving volts and your capacitance in farad, you check for the formula that will demystify this problem. And I guess that the formula will be formula number 2 because it contains capacitance and your voltage or your potential difference. So if we are using energy is equals to 1 over 2 CV square, we have that 1 over 2 times C. C is what? Capacitance, which is what? 10 raised to the power of minus 5. While your voltage is 12, so you have 12 square. So what do we have? 1 times 10 raised to power, 1 over 2 times 10 raised to power minus 5 times 144. And I guess this can demystify this to give you 72. So we have 72 times 10 raised to power minus 5. Wow. And if you convert your value, you have that the point is here. So you shift your point this way so that you have 7.2 times 10 raised to the power of minus 4 joules. Let's quickly check the question on the board and see the answer to our question. The solution to the question is what? Is A. Thank you very much. We have come to the end of this video lesson. We are going to continue from here in our previous class. Thank you very much. I'll see you in my next video.